Hello guys, and welcome back to the show. So in the last video tutorial, we saw how to set up an SBT project, and we actually set up the SBT project for this application. In today's video, we are going to learn how to create the server and the REST endpoint for this application. Let's get started. To do this, the first thing I'm going to do is basically to create a directory inside of the core directory. So I'll call this directory server. So I'll come over here and create a package. Then I'll call this server, like so. Inside of this server directory, I'm also going to create another file. I'll call this server. So I'll come over here and I'll create an object and I'll call this object server. Okay, so server. Now, inside of this server object, what I'm going to do is to define a method called stream. Okay, so I'll define a method called stream. Now, let us have a look at the Http4s documentation. So what we need to do is to basically create a Blaze server builder, pass it an effect type, the global execution context. Then we need to specify the port that we want to map our server to, and then we will provide it the root. Okay, so we are going to do something like this, but instead of explicitly specifying the effect type, which is the IO monad, what I'm going to do is to make this polymorphic in F, so that we can use any effect type that we want rather than committing directly to the IO monad. I'll show you how this is done. So the first thing I'm going to do is to basically copy the whole of this. Okay, go back to the application, and then I'll paste this over here. Okay, then let me import this. Let me get rid of this because I do not need this now. And then let me get rid of this. Okay, now rather than specifying that it is of type IO, I'm going to put an F over here. Now I can say that, okay, I'll provide a stream a high candidate type. Okay, and that F should have an implicit async. Okay, now this async type class comes from cat's effect. Basically, doing this is like saying I want an implicit F of type async of type F. Okay, so I'm saying that I want a type class instance of the F that I'll provide to stream. Okay, I will go back to how I had it initially, and now I will import the global execution context like so. But as you can see, we are hard coding the port that we want to bind our server to in here, and we are also hard coding the host over here. So what we could do is to write a simple configuration file that we can load at runtime, and then we can pass the configuration to application. So we can do something like that. So I'll come over here and create another directory called config. So I'll go here, package, and then config, like so. So now that we have this config package, what I'm going to do is to create a new object. So I'll call this object server config. Then I'll also create a final case class called server config. And this server config will have a port, because if I go to the server, I have a port which is of type int and a host which is of type string. So I will try to simulate this. Okay, so I'll create a port which is of type port. Then I'll create a host which is of type host, like so. So where am I getting this port and host from? Well, I want to declare another type called port and another type called host, but I do not have them now. So I'm going to create another package called domain. So package called domain, and inside of this domain package, what I'm going to do is to create a case class called port. I'll make this final so that it cannot be extended. So I'll call this port of type int, and this will extend from any val. So I'm using value classes. Then I'll create another one called host, like so. And I can say final case class host, which is of type string, and then extends any val, like so. All right, so now if I go to the server config, what I can do is to import this port from domain and the host from domain. Okay, initially I used pure config to basically load configuration into my application. But there is another library called Cyrus which can be used to load configurations into applications. I'm going to use Cyrus. So what I'm going to do is to copy this, go into my application, go into the dependencies, then I'm going to add this library to it. Okay, so I'll say val Cyrus here, and then I can say that this will be the Cyrus version, like so. I can import this, then I can go to the build.sbt, then I can say dependencies dot Cyrus, like so. Now that I have this sorted, what I'm going to do is to define a method called server config. I'll say define server config, and this will return a type config value. So if I check the config value, as you can see, it takes an effect type which is covariant in F, and then the return type which is of type A. So since we are not specifying the effect, we will put an F over there. Okay, so I'll specify the effect type, then I'll make it an async. Okay, and then I'll say config value of type F, and then I want the return type to be server config, like so. So now I need to provide the implementation of this method, and to do this I'll have a tuple like so, then I'll have an env, I'll call this port, then I'll say I want the port to be mapped to an int, and then I'll specify the port to be port 8080, and then I'll have another env which I'll call host, and I'll set the default to localhost, like so. Then I need to map the values to this type. Okay, so I'll say dot, let me import cat implicit to have the implicit instance for applicatives. So I'll say dot par map n, then I'll say port, and then the host. Let me wrap these inside of a bracket, and this will be server config. Then I can pass it port, and pass it port, like so, and pass it host, and then pass it host, like so. And now I have my server config. The next thing I'm going to do is to define a main config type, which will take all the configs that I'll have in my application, because I don't want to have to load server config separately, and then later on when I define Kafka config, have Kafka config as well, and then when I have Elasticsearch config, have Elasticsearch config as well. I want to have a main config type which will have all these configurations in it, and then I can have just one config which will have all these configurations in it. Let me show you what I'm talking about. So inside of this config directory, what I'll do is to create another object called config. Okay, so I'll come over here and create config, like so. Over here I'm going to create a final case class, then I'll call this case class config, and what this will have is that it will have a server config of type server config, and later on I can add the other configurations as a parameter to this type. You see what I'm talking about later on as we progress through this project. I'm going to repeat the same thing that I did in server config. So what I'm going to do is to define config type, and the return value will be config value. Then I can say server config the map, then I'll provide it this server config, like so. So later on I can have the Kafka config, the Elasticsearch config, and all the configs that I want in here as well. The next thing I'm going to do is that inside of the core, I'm going to create a file that I'll call main. This main object will extend from IO app. For now, let us think about the IO app as the primary entry point to a Captivate application. Okay, so since we have the IO app, we need to implement. So if I go into the IO app, it has this run method. So this has been implemented. This has been implemented, but it has a run method which has not been implemented. So I need to implement this run method. Okay, so I'll go into the main and I'll say def run, and this returns an IO of type exit code. Okay, so what I'm going to do is that I'm going to have a for comparison over here, then I'll have a yield like so, and then what I will say is that application config, or I can say config, will be fs2 stream. So import fs2 the stream, fs2 is basically a functional streaming library that we have in Scala. It is very powerful. I don't want to get into the details of what fs2 stream is, but it is a streaming library that we have in Scala, and it works with Kafka. So what I'm going to do is to say stream.eval. So stream.eval is basically used to lift, okay, a type of an f of a type into a stream of an effect type, and the return type will be that type. So what I'm going to do is that inside of the main, I want to lift the configuration into a stream. So I will say config, let me import this config.config of type io.load, like so. The next thing that I am going to have is that I need to have the server. Okay, so I can say server, and the server will basically be this server object. And now I will say that I'll pass it a config of type config, like so. So I'll copy this, go to the main, and then say server, okay, dot stream, and the effect type that I need to pass is the IO monad, and then I'll pass it there config, like so. Okay, but now this is returning an IO of a unit, and this is returning a stream. Okay, so what I can do is that I can go over here, and instead of doing compile and drain, I can remove this compile and drain. What compile actually does is that it goes to a namespace that has got a method called drain, which will basically convert the stream into an F type. Okay, but I do not need that over here, so I'll leave this as the return type to be return type of a stream of type F and exit code. Okay, and then I can specify the port to be config dot server config dot port dot port. Or what I could actually do is that instead of even calling this port, I could say value. So I can go over here and then change this to be value, like so. Then I can go to the server and then say port dot value. And I can do the same thing for the host. So I can say config dot server config dot host, like so. And let's see why this has been crossed. So it is deprecated. So what I'm going to do then is to use the apply method. Okay, that's fine. One thing that I also want to do is that I want to log to the console when the server actually starts. So I will add another type class over here called console, which I can get from Kafka. So let's go to the Kafka documentation and let's add the dependency that we need in order to have the console. Actually, we have the console, so let's see if I do. Yeah, we do have console. Okay, so I'll have this inside of a for comparison. So I'll say for, I'll have fs2 the stream, so I'll put fs2 the stream. So I'll say stream dot eval. So this stream is conflicting with this stream, and actually this stream must be a small s, so a lowercase s. So yeah, I will change it in the main as well. So if I go into the main, I can now change this to be like that. Okay, if I go back to the server, I can have the console type class, and I'll pass it an f. This is the effect type. Then I can say print line starting. Then I can put this inside of a stream, so I can say stream.eval and this. Okay, then I can say server will be this, like so. Then I'll have a yield, and actually let me yield the server. This will work, but it will not map to any REST endpoint, but at least we do not see the red lines, so it is fine. The next thing I'm going to do is to actually create the root that we will use inside of our application. So I'll go into the core directory, I'll create a new package, I'll call this package HTTP, and instead of this HTTP package, I'm going to create another package called root. Okay, so route, like so. Instead of root, I'm going to create an object, and I'll name this object event root.scala. Okay, so actually let's use a case class. Okay, so I'll call this event root like so. So now I can say that my event root, I'll pass it an effect type like so, which is of type async. So I actually have not decided what I'll pass to the event root, but I'll definitely pass something in there. But for now, let's leave it empty. And then we can say that this event root extends from the Http4s DSL like so. And this Http4 DSL takes an effect type, so we can pass it the F. Okay, so I'll go to the event root and then pass it the F. So now we can actually create the root that we want. Okay, so I'll define a variable called root. This will be of type HTTP roots of the type F, and it will be HTTP roots.of F. And for now, what we want to do is that if we have a GET request to the /endpoint, what we want is to return an OK response with hello, just for now, so that we can test that actually everything is working before we actually modify our root to take in a post request. So I'm sure people are wondering, what is this HTTP root? So let's go into HTTP root. So HTTP root is basically a Kleisli with a request input and a response output. The way that I like to think of this is basically a function that takes in a request and returns a response. This is how I think about Kleisli. Okay, so we can go back to the root, and now what I'm going to do is to have a prefix. Okay, so I'll create a private val, I'll call it prefix, and I'll call this prefix /API/v1, so version 1, and I'll make this private inside of the roots like so. Then I'll make this private as well. The next thing I'm going to do is to define a router, which will basically map this endpoint to the HTTP root. So to do that, what I'm going to say is that val router, and then I will say that if anyone goes to this prefix, so if anyone goes to /API/version1/event, what I want you to do is to map this to the root. So now if anyone sends a request to /API/version1/event, what will happen is that that request will be sent to this root. The next thing that I'm going to do is to actually use this root inside of the server. So I'll go to the server. Let me change this to value as well, just to make it consistent. So I'll change this to value. Then I'll say with HTTP app. Then what I'm going to do is to pass it this. So I'll go to the server. Then I'll say event root of type F dot router dot or not found, like so. So now I have a server which has a method called stream, which returns an fs2 stream of type F, which is the effect type, and an exit code. Okay, I'll go into the main of the application. So I'll go into the main. As you can see, this run method is currently returning a stream with an effect type IO and a return type of a unit. But what I need to return is an IO of type exit code. Okay, so what I'll do is to return a server, which will give me a stream of type IO as the effect type and the exit code. Okay, I need to make this an IO. So what we can do is to use the namespace that we talked about. So I'll wrap this inside of a bracket. Okay, and I'll say dot compile. So when I run compile, I go into a namespace which has a method called drain, because I do not want the results of the stream, okay, dot as exit code dot success. So basically I have everything set. So if everything is working correctly, if I should start the server right now and go to /API/v1/event, I should see hello being printed out. Let's see if we actually get this. So I'll go to the main, and then I'll click on this. So if I go to localhost to port 8080/API/v1/event, I get hello. So now what we can do is to modify our root so that it is able to accept a post request with the data that we want in the request body and then we can do whatever we want to do with that later on as we progress through the project. Let's see how we can do this. To do this, what I'm going to do is to go inside of the domain, and I'm going to create a new type called event. So case class, I'll call this event, like so. And when someone sends the request, I want the body of the request to have a username of type username, a message, mood, which will be of type mood. So if the person is feeling great, if he's feeling bad, if he's feeling, the mood that the person will be in, then I'll add regrets, which will be an option of type regrets. So if the person regrets not doing anything, the person can put in a regret. So basically, every day, I try to write down a message of what I did, how I'm feeling, and if I have any regrets, if I think I could have done something that I didn't do. And I usually write this in a notepad. So this application can be a great application for me to put down these events that happen in my life. So every day I can put in my name and I can put in a message, which could be any message that I want. I can put in how I'm feeling, which is the mood that I'm in, and I can put in if I have any regrets for the day. Then the last thing that I will do is to write what I plan to do the following day. So I can say plan to achieve, okay? Which is of type plan to achieve. And since this is optional, let me put this over here, like so. As you can see, I do not have anything called username. I do not have anything called message. I do not have anything called mood, and so forth. So what I'm going to do is to create all these types just to make them not read anymore. So I'll come over here and I'll create a case class called username. So I can say regrets. I can have regrets, which extends any val. Everything is looking great right now. So let's try to modify the HTTP route, which is the event route, to accept this event type as a post request, and let's see what happens. So I'll go to event route. Currently we are expecting a get request, but now we're going to change this to a post request. Okay, so I'll make this a post request. Oops, let's make this a post request like so, and let's call this thing a request. So we do that in Scala using the @ and then request like so that we can use this request inside of the route. Okay, and now I will say that, okay, I will get a post request. What I want to do is that I want to attempt to decode this request. So I'll say request dot attempt as. Okay, so I'm saying request dot attempt as. So if I go into attempt as you can see, attempt as expects an implicit decoder, which is an entity decoder of the effect type and the type that I actually want to decode. Okay, so what I actually want to decode is this event. Okay, so I'll copy this, I'll go over here and I'll say attempt as event like so. But as you can see, it says that there is no implicit decoder of type entity decoder with the effect type F and a return type event. So what is this decoder? Let me show you what this decoder is. Now, this is a JSON placeholder. So let's use this JSON placeholder as an example. So basically in this JSON placeholder, we have a JSON. Okay, so this is a request. The request method is a post request. And then the body of the request is this. Okay, the body of the request is a JSON. So it has a title, the value is full, and the body, the value is bar, and then the user ID, which is of type integer, and the value is 1. Now, what we are actually trying to do is that when we get this, okay, when we get this JSON, what we are trying to do is to decode this JSON into a Scala type. Okay, we want to transform this JSON from how it is sent to a Scala type. But as you can see, we do not have a decoder for the event type. So we now need to create a decoder for the event type. And once we've created a decoder for the event type, we will not see this error anymore. So now let's see how we can create the decoder. Okay, I'll go to the types, go into events. And now this event type has got this username, message, mood, what I plan to achieve, and then regret. So I now need to create a decoder for all these types in order for this to work. Now to do this, what we're going to use is we're going to use a library called Circe. So Circe is a JSON library for Scala, which is powered by Cat. So basically what I'm going to do is to copy this, go to the dependencies. I'm going to add Circe like so. So let me add the version. Let's make this private. Circe version. Let's call this var Circe, which is a sequence. And let's build this. The next thing I'm going to do is to add one more library, which is the Circe generic extra. So I'll go on to Maven repository and then copy the Circe generic extra library. Come over here and then paste this here. Okay. So I'll say var Circe generic extra, which will be this, like so. Then I can have a private file. Circe extra version would be this. Okay, and then I can have this over here like so. So the final thing that I'm going to do is to go into the build.sbt. So into the build.sbt file, and I can say dependencies dot Circe generic extra, and then let me also add the Circe library. So this one. So I'll say dependencies dot Circe like so. Now that we have everything, let us go into the event. Let's go into username and let's add the decoder for username. So I'm going to create an object and then the codec. So I'll give it an implicit codec, and this codec will be a derived unwrapped codec for username. And I can say import io the Circe the generic dot extra the semi-auto dot derived unwrapped codec like so. Okay, and then let me copy this and let me put this here. All right, so let's see what a codec is. So if I show you what a codec is basically a trait which extends from a decoder and an encoder. So basically when I have a codec in scope, I have an implicit encoder, which is basically something that can convert a Scala type into a JSON, and then a decoder is something that can transform a JSON into a Scala type. So rather than explicitly stating what the encoder will be and what the decoder will be, I'll just have a codec, and a codec will give me both an encoder and a decoder. I hope this makes sense. So now I'll go into message. I'll create a companion object. Then I'll have this as well. But this time it will not be username. This time it will be message like so. One thing that I also want to talk about is how implicits work in Scala. When a type needs an implicit value, Scala first checks in the companion object of that type to see if that implicit has been defined in there. If that implicit has not been defined in there, then it will look outside of the companion object to look in the scope that the type has been defined in to see if it can find the implicit in there. So I can now go to the event again and do the same thing for mood. Okay, so for mood, I can have a companion object like so. And then I can have the regrets as well. So let me copy this like so. And then I will make sure that I do have the type annotation. I have regrets. I've got username. And then the last one that I need to sort out is the what I plan to do. Okay, so what I plan to achieve. So I'll have an object. Now that I have this, what I can do is to go to the events type, and then I need to also provide a codec for the event. Okay, so I also have to create a companion object for event, and this event will have a configuration. Okay, so I will say implicit config, and this config will basically be this configuration. Okay, so I'll copy this, and the configuration that I want is the default configuration, and now I need to provide it the codec. So I'll say implicit val codec, and this will be a derived config codec. So I'll say derive. Let me import this. So I'll say import dot semi-autos dot derive config codec. So this is what I need, and now I can say this will be a derived config codec of type event like so. And this configuration is basically from the Circe generic extracts. Okay, so now we have everything sorted. So let's go back to the root. So basically we have a decoder which basically transforms a JSON into a Scala type. We also need an entity decoder. Okay, so let me show you what this is. On the Http4s documentation under JSON handling, as you can see over here, it says that to get from an HTTP entity to JSON, we use an entity decoder, okay, of type JSON. So basically, we need to provide it an entity decoder so that it can go from an HTTP entity to a JSON, which will then be transformed from the JSON to the type that we want, which is the event type. Okay, so right now what we have is a decoder which is able to convert a JSON into the event type that we have, but we don't have anything that can transform an HTTP entity to a JSON, which will then be converted to the event type. So let's create this entity decoder, and we can basically just copy this, and then inside of this place, what we're gonna do is to add this. Okay, so I have the decoder, entity decoder. This will be a JSON of type F and the event, okay, like so. It looks like I do not have the library that will make this in scope, so I need to add the Http4s Circe. So what I'm going to do now is to go to Http4s documentation and then add this library Http4s Circe. Okay, so what I'm going to do is to copy this, go back over here, and then say val Http4s Circe will be Http4s. Then I can pass it the Circe, and then I'll build this. So I've also added it as a dependency over here. So Http4s Circe. So now if I go into the event routes, I can now import this fold F. So what the fold F will do is that I'll give it something to return in case the passing of the body of the request that I send, if it fails, what it should return, and if it passes, what it should return. So fold F. So the first one is if it fails, what I want you to do is to return a bad request with a message, an error occurred, the request body, like so. So this is in case it fails, and then if it passes, what I want to return is basically a created. Okay, so I can say created like so. So now let's build and see if everything works as we expect it to. So we build the application and everything is working. So let's start the application and let's check if everything is working correctly. So what I'm now going to do is to go into the main. I could run this from the terminal if I want to, but let's run it from here. Starting the server. So we know that the server has been started. So now let me use Postman to send a request with the body that we expect, and let's see if we actually get a created response. Okay, so I'll go on to Postman and actually went ahead and then sent a request to the server. So I went to /localhost port 8080 API version 1/event. Then I sent this request with the username, message, mode, and what I plan to achieve. And as you can see, I get a created over here. So it means that our application is working correctly. The next thing that I'm going to do is that since we'll be sending a lot of requests to our application, I'm going to create a bash script which will basically send a curl request with this body, and then we can use the same body every single time. So what I'm going to do is to go to the terminal. From the root of our application, I'm going to say touch test server.sh, and I'm going to say chmod +x so I can execute it directly. So I've gone ahead and created this so that I can reuse it every single time without actually going onto Postman and creating the request from Postman. I still have the server running, so if I do .testserver.sh, as you can see, the request has been created. So I know that everything is working correctly. So that is it for this tutorial. So in the next video tutorial, what we are going to do is to integrate Kafka into this application. What we are actually going to do is that when the event is sent, rather than right now just returning created, we will publish the event to Kafka, and then we can do something with it later on. Thank you guys for watching, and I'll see you in the next video tutorial.